we need to find s, the speed of the tsunami. We can find this using the given formula. S is equal to the square root of g times d. To use this, we'll need to identify the values of g and d. G is given to us directly. It's 9.8. D is the depth of the ocean in meters. We're told that we have a depth of 2,000 meters, so D is going to be 2,000. Subbing these values in, we get the square root of 9.8 times 2,000. Typing this in our calculator gives us our final answer of 140. And the units here are meters per second. We need to find the time it takes the tsunami to reach land. The distance, speed, time triangle is useful here. Whichever quantity we want to find, we cross this out and the triangle will tell us the formula to find it. We need to find the time. Crossing this out in our triangle leaves distance over speed. So our formula is time is equal to distance over speed. Let's try to find both these values. For the distance, we're told that our tsunami begins 400 kilometers from land. We'll need to be careful with our units here. The speed of the tsunami is measured in meters per second, so it'll be a good idea to convert this distance to meters as well. 1 kilometre is equal to 1,000 metres. So to convert from kilometres to metres, all we need to do is multiply by 1,000. This means that 400 kilometres is equal to 400,000 metres. So this is our value for the distance. Now, let's think about the speed. In part I, we found that when the depth is 2,000 metres, the speed of the tsunami is 140 metres per second. Since we also have a depth of 2,000 metres in part II, we can use this calculation we had earlier. Our speed is going to be 140. So, distance over speed is 400,000 over 140. This comes out as 2,857.1429. Since our speed is in meters per second, the unit here will be seconds. However, we need to give our answer correct to the nearest minute. To convert from seconds to minutes, we divide by 60. This comes out as 47.6190 minutes. We want our answer correct to the nearest minute, so to get our final answer, we should round this off to 48 minutes. The formula we are given is S is equal to the square root of G times D. To rearrange this formula to give D in terms of G and S, we need to isolate the D all by itself on one side of the equation. In other words, we need to end up in the form D is equal to something. The D appears on the right-hand side, and there's quite a few things going on around it. It's being multiplied by G, and all of this is under a square root. To isolate the D, we'll need to get rid of the square root, and we'll need to get rid of the G. When we're removing things, a good principle is to start from the outside and work your way in. The outermost layer here is the square root, so this is what we should target first. To get rid of something in an equation, we should perform the inverse or opposite operation to both sides. The opposite of a square root is a square, so here let's square both sides of our equation. The square root will cancel with the square, so we end up with s squared is equal to g times d. Now let's get rid of the g. This is being multiplied by the d. To get rid of it, we should do the opposite, which is division. So the next step is to divide both sides by g. Multiplication by g will cancel with the division by g, so we end up with a final answer of d being equal to s squared over g. We need to find the depth of the ocean d. In part I, we found a formula to calculate d. D is equal to s squared over g. Once we identify the values of s and g, we can sub into this formula to get our answer. S represents the speed of the tsunami in meters per second. We're told that the speed is 55 meters per second, so S is equal to 55. G is given to us directly in the question. G is equal to 9.8. Subbing in these values, we get D equal to 55 squared divided by 9.8. Putting this in our calculator gives us 308.6735. We need to give our answer correct to the nearest meter. So rounding this off, we get our final answer that the depth, D, is equal to 309 meters.